Hi, in this video we are going to be discussing about change of base of logarithm. Now, you sometimes need to change the base of a log. A logarithm in base b can be written with a different base c using a change of base rule. So, the change of base rule says that if we have log to the base b of a and we have to to a, express this with a different base c, let's say. So, for example, uh, we have to express log to the base 5 of 2 as log to the base 4. Then we can express this as a log to the base 4 by writing this as log to the base 4 of the value of the value 2 divided by log to the base 4 of 5. So the rule says log to the base b of a can be expressed with a different base c by writing it as a fraction log to the base c of a divided by log to the base c of the original base b. So that's our change of base law rule. So what's the proof? The proof is that if x is equal to log to the base b of a, then we can convert this into the exponential form by writing b to the power of x equals to a. Now, if we have an exponential equation b to the power of x equals to a, we can introduce any log on both the sides. So let's take log to the base c on both the sides. Log to the base c of b to the power of x is equals to log to the base c of a. Using the power rule, we can bring down x over here and we can express this as x times log c of b equals to log c of a. So x value is equals to log to the base c of a divided by log to the base c of v. And what was x? X was equals to log to the base b of a. So log to the base b of a is equals to log to the base c of a divided by log to the base c of b. That is our change of base rule. Now, if c is equals to a, for example, log to the base 5 of 2, and we need to express this as log to the base 2. So we are going to write this as by applying the change of base rule. We are going to write log to the base 2 of 2 divided by log to the base 2 of 5. Now log to the base 2 of 2 is always 1 divided by log to the base 2 of 5. So log to the base 5 of 2 becomes 1 upon log to the base 2 of 5. So the rule says that uh, if the value of c and a are the same, or let's say we have to express log b of a as log a of b, so log b of a is just going to be equal to 1 upon log a of b. That is the rule. Okay, let's try to understand this with some examples. Log 3 of x equals to log 9 of x plus 6. Now we can see that we have different logs, and it's better to apply the change of base rule so that we can have same base logs to solve the equation. So I can change log to the base 9 of x plus 6 by introducing a new log to the base 3. So log 3 of x plus 6 divided by log to the base 3 of 9, and this is equal to log to the base 3 of x. Now we have same logs to log with same bases on both the side. Okay, so log to the base 3 of x plus 6 divided by log to the base 3 of 9 is just 2 equals to log to the base 3 of x. If we cross multiply this, we are going to get 2 times log to the base 3 of x equals to log to the base 3 of x plus 6. Using the power rule, we can take this 2 as a power of x. So log to the base 3 of x square equals to log to the base 3 of x plus 6. Now this means that x square is equals to x plus 6. So therefore x square is equals to x plus 6, which means that x square minus x minus 6 equals to 0. And solving this, we are going to get two values of x. The two values are 3 and minus 2. Now we are going to confirm our values. If we take x equals to 3, this value is a positive number and the log on the left hand side is defined. This value is also a positive number, so the log on the right hand side is also defined. So x equals to 3 is the correct solution. But x equals to minus 2 is not, because if we take x as minus 2, this log won't be defined. So we are going to neglect this value. We are going to reject this value because log 3 of minus 2 is not defined. So that's x equals to 3 is the only answer. Let's consider this example. Given that log to the base p of x equals to 20 and log to the base p of y equals to 5, find log to the base y of x. Okay, so we need to find log to the base y of x. So log to the base y of x, if we want to express this as a log to the base p, we are going to write log to the base p of x divided by log to the base p of y. And the value of log to the base p of x is 20 and log to the base p of y is 5. So the answer comes out to be 4. The second part says log to the base p of x equals to 15 and log to the base p of y is equals to 6. Find log to the base x of y. Again, we can introduce a log with the new base, that is log to the base p of y. So we are going to express this as a fraction by applying change of base rule. Log to the base p of y divided by log to the base p of x. Log to the base p of y is 6 and log to the base p of x is 15. So 6 upon 15 is 2 upon 5, which is equal to log to the base x of y. Okay. Let's consider another example in which we have been asked to express log to the base 4 of x in terms of log to the base 2 of x. So log to the base 4 of x needs to be expressed in terms of log to the base 2 of x. So we can write log to the base 2 of x divided by log to the base 2 of 4. Now log to the base 2 of x divided by log to the base 2 of 4. Log to the base 2 of 4 has a value and that value is 2. So this is half times log to the base 2 of x. Part B says, using your answer of part A and the substitution u equals to log to the base 2 of x, solve the equation log to the base 4 of x plus log to the base 2 of x equals to 12. Okay, so log to the base 4 of x, we already know that log to the base 4 of x is equal to half times log to the base 2 of x. So in part B, I can substitute this as half times log to the base 2 of x, and then we have log to the base 2 of x equals to 12. And then the question says substitute u as log to the base 2 of x. So this simplifies down to half u plus u equals to 12, which is 3 upon 2 u equals to 12, which gives us u as 12 times 2, 24 upon 3, that is 8. So if u is 8, then that means log to the base 2 of x is equals to 8. So to find the value of x, we can convert this into the exponential form, which is 2 to the power of 8, that is 256. Alright. Express log to the base 4 of x in terms of log to the base 2 of x. Again, the same working. Log to the base 4 of x is going to be equal to log to the base 2 of x divided by log to the base 2 of 4, which is log to the base 2 of x upon 2. Hence the answer is half log to the base 2 of x. Part B says express log to the base 8 of y in terms of log to the base 2 of y. So log to the base 8 of y is log to the base 2 of y divided by log to the base 2 of 8. Okay, so this means log to the base 2 of y divided by log to the base 2 of 8 is 3. So that is 1/3 of log to the base 2 of y. Now the question says, hence solve the simultaneous equation 6 log 4 of x. Now log 4 of x, log 4 of x answer came out to be half log 2 of x. Okay. In this question, we have to solve the simultaneous equation 6 log 4 of x plus 3 log 8 of y equals to 16, and the second equation is log 2 of x plus 2 log 4 of y equals to 4. These are the two equations given in the question. So for the solution, we are going to replace log to the base 4 of x with half log 2 of x plus 3 times log 8 of y. Now log 8 of y reduces down to 1/3 of log 2 of y. So 1/3 of log 2 of y, and this is equal to 16. So the first equation reduces down to 3 log 2 of x plus log 2 of y equals to 16. And the second equation is log to the base 2 of x plus now 2 log 4 of y. 2 log 4 of y needs to be further simplified. 2 log 4 of y would mean log 4 of y means log to the base 2 of y divided by log to the base 2 of 4. Since everything is in terms of log to the base 2 of x and log to the base 2 of y, we would like to keep it in that form. And if it's not in that form, we are going to apply change of base rule to bring it in that form. So log, it's going to be 2 times. So if we multiply this by 2, now the answers reduces down to 2 times log 2 of y divided by log 2 of 4 is 2, and the final answer comes out to be log 2 of y. So 2 log 4 of y is equal to log 2 of y, and that is equal to 4. Now to solve this, we can substitute log to the base 2 of x as, let's say, s, and log to the base 2 of y as t. So our equation would become 3s plus t equals to 16 and s plus t equals to 4. If we solve these two equations, we are going to get the values of s and t. So solving these two equations simultaneously will give us two values, one value for the s and one value for the t. So s comes out to be 6 and t comes out to be -2. So s was substituted for log to the base 2 of x, which is equal to 6, and log to the base 2 of y is equals to, was substituted for t, which is equal to -2. So x is equal to 2 to the power of 6, that is 64, and y will be equal to 2 to the power of -2, which is 1/4. So the values of x and y are 64 and 1/4. Thank you for watching this video.